I'm Heather with Team Gigabytes, and we're here to present an exciting technology currently in development. Here's Chris with the events that inspired the robot.
Disasters, whether man-made or natural, often create situations far too dangerous for human rescue teams to safely navigate or work within. On the 11th of March 2011, Japan's Fukushima Daiichi nuclear power plant was hit by a devastating tsunami. The incoming water flooded the lower levels of the plant, destroying the cooling system for the reactors. Soon, the levels of radiation within the damaged reactors became too hazardous for emergency crews to try and repair. Although robotic aid was used to clean up during and after the Fukushima disaster, the robots were not able to navigate some sections of the rubble, and it became clear that better robots were needed.
What kind of technology could such an event possibly inspire? Here's Dean with the answer.
Inspired by both the Fukushima meltdown and Deepwater Horizon's underwater oil spill, the U.S. Defense Advanced Research Projects Agency, also known as DARPA, decided to create the DARPA Robotics Challenge. The goal of the Robotics Challenge is to create an agile and mobile robot that will be able to work in disaster zones unfit for humans, performing the necessary tasks to clear the rubble and restore the environment to the state that is safe for humans to operate in. The robot should also need minimal guidance from its humans and will remain at a safe distance from the working zone. One robot currently in development is the Atlas robot, funded and designed both by DARPA and Boston Dynamics in collaborations with the Sandy National Laboratories and iRobot. The Atlas robot is intended to conquer the wildest of landscapes by using 2 legs, so its upper limbs are free from maneuver objects in the surroundings. However, in the roughest terrain, the Atlas is capable of using both lower and upper limbs to navigate through clogged spaces. The unique feature is the hands. The hands are designed so that Atlas may manipulate tools just as a human would. The Atlas includes a body comparable to that of a human: 2 hands, arms, legs, feet, and a torso. Another superior feature is the head. The head contains a stereo cameras, a laser rangefinder, and a powerful from off-board electric supply via flexible tether. Several Atlas robots are currently in development as DARPA Robotics Challenge program.
Well, what can the robot currently do? I'm here to tell you.
DARPA's contest is intended to create robots that can traverse difficult terrain, enter, exit, and drive a vehicle, and perform simple motor tasks such as attaching a hose to a spigot. Such a robot will need to perceive and correctly respond to the layout of its environment. It must have sufficient sensors to create an accurate mental model of the environment and adaptive, flexible programming that will allow it to plan and execute the appropriate actions. It also needs to carry its own power supply. Atlas is capable of using a laser scanner and cameras to make a workable map of its environment. So far, its movement has been refined enough to walk over moderate rocky terrain and balance when struck unexpectedly. Atlas is still not capable, however, of navigating more difficult terrain, such as that typically found at disaster sites. It is capable of manipulating objects, but only with direct commands to do so. It is not capable of making decisions to move an object, such as a heavy beam in its way. The robot is also still dependent on external power sources fed into the robot through cables. Getting Atlas untethered will require a complete rearranging of the machinery in the torso to create a suitable location for a large integrated power source that will not upset its balance or weigh it down to the point of immobility. Current development on the robot is focused on making Atlas more independent, both from external power and from the need for constant user commands. Development on the robot is intended to continue long after the end of the contest. It is estimated that developing Atlas to its full potential might take a decade or more, although the competition has made a considerable amount of progress on the robot in a relatively short period. It will still be some time before Atlas is unleashed on the greater world.
Sounds like the robot still has a lot of technical issues. LaShawn, will the robots face any issues outside of the lab?
The most significant problem facing use of the Atlas robot is that it is unfinished, and its future capabilities are unknown. Atlas is slow in its current state and cannot be used for applications where quick responses are required. Unfortunately, the robot is also not very precise, and even clearing rubble is a difficult task at present. It weighs around 330 pounds, even without a portable power source, and it could potentially collapse a weakened structure. Hopefully, by the end of its long development cycle, these issues will be addressed and it will be ready for deployment. Even then, there are still further potential problems. If a company were to buy an Atlas robot, the robot would need a trained technician to operate as well as to maintain the robot. Cost effectiveness is a major concern. Atlas is likely to be a very expensive tool, even before the cost of an operator and mechanic, and at first it is possible that only major cities will be able to afford one. Atlas was designed by Boston Dynamics with funding from DARPA. DARPA announced that they would not use Atlas for combat purposes. Organizations such as United Nations could put the robot to use for rescue missions and enter dangerous situations where a human cannot enter. Atlas would be perfect for situations such as a nuclear reactor disaster, where people cannot get close enough to prevent a major loss.
If we can't deploy it now, what might we be able to do with it in the future? Chad?
The Atlas robot is still in very early development stages. However, there is already considerable speculation regarding the potential uses of the final design. Potentially military applications include aiding soldiers in daily operations or even, once modified, participation in battle. The medical field could find use for the robot in situations where areas are infected with highly contagious diseases, such as the Ebola outbreak in Liberia. This would allow physicians to consult and diagnose patients without exposing themselves to pathogens, helping to limit the spread of the disease. Patient care could extend to assisting the elderly and disabled with daily tasks that might be difficult for them to perform. Another field the robot could specialize in is disaster relief. Atlas will be especially useful in radioactive areas, similar to the damaged Fukushima power plant. It is not safe for human workers to enter highly radioactive areas, but in these situations the robot would be able to safely assist in the cleanup process. The Atlas robot would be beneficial in all these scenarios. However, it would need to have improvements in mobility, dexterity, and durability in order to function properly. With these improvements, would it be cost-effective in the future to purchase the robot for these tasks? Human lives could be saved by limiting the risks they would have to take, but could your local municipality be able to afford such a useful tool? It is possible that the Atlas project, after completion, will not be seeing widespread use due to lack of funding.